We look at the starting equation equals tan squared plus cot squared. We do this to see what we need to solve. This is our starting point. We write dy divided by dx equals the derivative of tan squared plus the derivative of cot squared. We do this to show we will find the change for each part separately. The rule says the derivative of sum is the sum of the derivatives. We plan to use the power rule and the chain rule for the first part and the chain rule for the second part. We do this to pick the right math tools for each piece. Each part has different shape that needs specific rule. We rewrite tan squared as the quantity tan squared. We do this to see the inside part clearly. This helps us use the chain rule later. We note that the derivative of tan is sec squared and the derivative of cot is negative csc squared times 2 divided by dx. We do this to remember the rules we need. These are standard math rules for these shapes. We apply the power rule to the first part to get 2 times tan to the power of 1 times the derivative of tan plus the derivative of cot squared. We do this to start solving the first piece. The power rule says we bring the exponent down and subtract 1 from it. We let equal tan so that 2 divided by dx equals sec squared. We do this to find the change of the inside part. This is the first step of the chain rule. We simplify the first part to get 2 tan times sec squared plus the derivative of cot squared. We do this to make the equation shorter. We used the result from our previous step. We let equal squared so that dv divided by dx equals 2. We do this to find the change of the inside part for the second piece. This is the first step of the chain rule for the second part. We apply the chain rule to the second part to get negative csc squared of squared times the derivative of squared. We do this to solve the second piece. The chain rule says we multiply the outside change by the inside change. We prepare to put all our pieces together into one long line. We do this to finish the math problem. We must combine every part we found. We find the derivative of squared, which is 2, and put it in the equation to get 2 tan times sec squared plus negative csc squared of squared times 2. We do this to complete the calculation. We are following the rules we set before. We clean up the expression to get 2 tan times sec squared minus 2 times csc squared of squared. We do this to make the answer easy to read. We move the negative sign to the middle. The final answer is dy divided by dx equals 2 tan times sec squared minus 2 times csc squared of squared. We do this to state our final result. This is the completed math work.